to everyone. So, no, that's not what I need. I need this one. Okay. Lots of things to wear here. So, I've asked your friends here in class to do this job for me. We are going to our last family of functions, and they're called exponents. And what I've asked you to do, what I've asked them and you as well, do is look at these two equations. Okay? Y equal 2 to the power of x, y equal half, in brackets, power x, and just sketch those two graphs onto the same axes, okay, by first of all filling up this table. So in other words, finding the y values for these x values, minus 3, minus 2, minus 1, 0, 1, 2, and 3. So you've got to do that, fill up this table for those two functions separately, and then sketch both of them onto your axes. It's important that you do that first before I actually draw the graph, just so you get the feel of that graph. Okay, and I'll see you in a minute. Okay, guys, so hopefully you did this little exercise, and what you found is graphs that look like this. Okay, so the y equal 2x, I usually speak about it as like an airplane that is taking off and flying, and the y equal half power x is an airplane that is just landing. Okay. And what is the y-intercept for both of them? Where do they cross the y-axis? 1. Okay? So they cross at 1. Okay? There is that point 0, 1. They both intersect there. Okay? Now we also, and we start using that word a week ago, there is an asymptote. Yeah. Can you identify the asymptote? Pause here for Okay, so the people here identified a horizontal asymptote. Okay, we've got the horizontal asymptote here. Okay, which is y is the line y equals 0. Both these graphs get closer and closer and closer to it, but never really crosses it. Okay, the y equal 2 power x will get closer as x equal to minus infinity. And the graph y equal half power x will get closer and closer to x equal infinity, but they'll never really cross it. Okay? Now, the family of functions that we're looking at, okay, is this. Okay? It looks a little complicated. Y equal a times b to the power of x plus q. But as always in math, we start with simple, and then we build up to the more complicated. So we today are only just going to look at b to the power of x. We're going to add the a and the q later. Okay? Now, what are we going to keep? What's that condition to be? Okay? B must be larger than 0. So we're not going to have a negative number power x. To add that negative number, we're going to multiply it by a later. But for now, we're just looking at b power x, where b is positive. But we can see already there's two kind of graphs. Okay? One, okay, when b is larger than 1. If b is larger than the 1, like for example 2, then we're going to have airplane taking off. Where if b is smaller than 1, let's say half, okay, then it lands. Does that make sense? Okay, let's try and understand a little bit in terms of numbers. Okay, so looking at y equal 2 to the power of x, this is an example where b is larger than 1. So let's have a look at what we've done here. Okay, so we'll start with 0. 2 to the power of 0 is 2 to the power of 1. 2 to the power of 1 is 2 to the power of 2 is 4. 2 to the power of 3 8. 2 to the power of 4 16. 1 more, 2 to the power of 5 32. So what we can see here is an exponential increase. If you look at these values of y, 1, 2, 4, 8, 16, 32, they're not just going up. Okay? They're going up in a higher and a higher increase. And that obviously, or the rate of increase increases as well, if you know what I mean. Okay? And what does that remind you? We kind of mentioned that. Today's COVID, okay? So when we look at number of people infected, okay, around the world, globally, then we often say it's exponential increase. This is what exactly this means, okay? It increases, and the rate of increases as well, okay? There was a question I gave you about statistics, and it's related to that, Okay, how many people each person infect? And they reckon that for COVID, it's around 2. Okay? A little less than 2, but let's say around 2. So if we saw 1 patient infected, then it's 2, then we get 4, because each one will infect 2. And then each one of these 2 will infect another 2, so it's 4. And each one of these will infect another 2, so 4 times 2 is 8. We every time multiply by 2. Okay? So if we do nothing about it, if we don't do social distancing, if we don't do closures, if we don't do all these restrictions, then it can just go on like that. Okay? Obviously, it's never going to go on forever. So even if we don't do anything, we just carry on as normal, it's not going to go on forever. Why is it not going to go on forever?
Everyone's going to get it.
Eventually, everyone's going to get it. And so you can't, unless some aliens come and start infecting them. Or, at some point, it's not going to go. Everyone's going to get infected, and hopefully immune to it. Okay. Right. Okay, now, what about that? Okay, what about when b is smaller than 1? Okay, so in the case where b is smaller than 1, let's just look at some of these. So, for example, y equal half to the power of x. So, half to the power of 0 is 1. Half to the power of 1 is? Yeah, or half. Half to the power of 2 is? A quarter. Let's just do one more. Half to the power of 3 is? 8. So you can see that that number decreases, so the rate of decreases. So 1, half, quarter, 8, 16, 1 over 32. It carry on getting closer and closer to the 0, but it will never reach it, isn't it? It will never reach it. Okay? So that's the exponential graphs. You have either exponential increase or exponential decrease, which we normally call exponential decay. Yeah, I don't think you guys do any radioactivity in grade 10. You should be doing it. Okay? But exponential, yeah, in science. Unfortunately, you're doing a little bit of radioactivity, it's good. That's an extra. It's not going to be for matric, but it's something that you should be learning about. Okay? So that's exponential decrease or exponential decay, and this is exponential increase. Okay? Right, let's do some work now. We are in page, okay, I'll give you the instruction. See you guys later.